our next topic is to use the exponential functions, e to the x and others, to use those as models for real-world natural phenomenon settings. I'm on page 293 in the textbook, so if you have an electronic version of the text, you might want to see if you can find that. I'm on page 293. And this has a whole set of problems, or whole set of exercises using the exponential functions as models for real-world settings. And so we'll talk through several of these. Maybe for an example, I'm going to deal with, say, number 108. All right? And so we're given the following. The atmospheric pressure P. So P is equal to pressure. The atmospheric or the air pressure on a balloon or airplane, it decreases with increasing height. So as the altitude increases, the pressure decreases. This pressure, measured in millimeters of mercury, is related to the height, and so H is given to be the height, and it's actually in kilometers, above sea level. So P represents the pressure, H represents the height. And we are given, and in each of these problems that we'll be working, each of these exercises, you will be given a function. This function has been, these functions have been developed by professional people who have worked with these particular topics and have developed these models as approximations of the actual real-world setting. And so we're given this expression, P of H. So what that means is pressure is being expressed as a function of height. So instead of having F of X, we have P of H. So the pressure at any particular height. This is pressure. It's expressed as a function of height. And we're given that to be 760 times E raised to the power negative. Now this says 0.145. I usually don't write the 0 in front of the decimal. If you prefer to, that's fine. If I write it this way, I probably wouldn't get my textbook published. But I typically would write it this way. So it's 760 times E raised to the power of negative 0.145 times H. Now what this means is this. Given any specific value of H, this equation will produce the value of P. That is to say, given any height above sea level, and again this is measured in kilometers, these can be decimal values because you can have decimal values for kilometers. You could have 1.62 kilometers, for example. So given any height in kilometers, substitute that value into this equation, and that will give, according to this model, an approximation of the pressure, the air pressure at that altitude. So, for an example, suppose we wanted to find the pressure when the height is given to be, this is given, suppose the height, we can pick a number out of the blue sky, let's say 4.5 kilometers. Now, the science people probably wouldn't have much patience with me, but I'm going to suppress writing the units all the time. You might want to put the units when you get your final result. This pressure is in millimeters of mercury. The height is in kilometers. So you may want to put the final result using the units. I will suppress the units because what we're after here is finding the actual values mathematically. And then if the physicists and chemists want to use that to do their little work, that's fine too. So the procedure is straightforward. H is given to be 4.5. Substitute that into the function. So our solution is pretty straightforward. The pressure at 4.5 is given to be or is computed to be 760 e raised to the power negative 0.145 times 4.5. Sorry about that. And order of operations, parenthesis first, exponential second, multiply last. So this is going to be 760 times e raised to the power. And let's see if I can do my computation here. So first I need negative 0.145 times 4.5. Negative 0.145 times 0.45. And my value is negative 0.06525. I need to take e, raise it to that power. Now, if you're familiar with how this calculator works, you may, if I do the exponential function, remember, whatever the previous answer was, we can access that with the second function. Answer is at this location. So if I do my previous answer, it's going to give me e raised to the power of the previous answer. If your calculator doesn't have that capability or you're unfamiliar with it, simply type in the negative 0.06525. Close my parenthesis, hit the enter, and this quantity, e raised to that power, that's not our final answer yet, but that value so far is 0.9368. So I'm going to approximate that. 0.9368. Now, this is now an approximately equals. I'm not going to distinguish between those, so I will use this symbol to mean either equals or approximately equal as is appropriate. Now, I'm going to leave the decimal string in the calculator, even though I write it down as an approximation. If I leave the entire decimal string in the calculator, what's left is to take that value and multiply it by 760. So take that previous answer times 760, and my result is 711. Now I do want to approximate this final result. My value is 711.9932. Let's suppose I want to round everything in this assignment to 2 decimal places. So I would be 0.99. And so my approximation for the air pressure at the height of the altitude of 4.5 kilometers is 711.99. And if you wanted to have the units, this would be millimeters of mercury. Again, I'm not a stickler for that. Let the chemists and the physicists and meteorologists worry about that. For our purposes, all I'm after is if you can get the 711.99, you're going to be good to go.